indeterminate form of infinity over infinity. Suppose f and g are differentiable on an open interval I containing a with the g prime not equal to 0 on an interval I when x not equal to a. If the limit of the fx and limit of the g equals either positive or negative infinity as x approaches a, or we can say the limit of the quotient f over g. First, when you do the direct substitution, either in a form of positive or positive or negative infinity over positive or negative infinity. This is another quotient indeterminate form. So we use L'Hopital to find the limit of this quotient by finding the limit of the derivative of the f divided by the derivative of the g. Examples, evaluate the following limits. Limit of 3x to the fourth minus x to the second divided by 6x to the fourth plus 12. As x approaches infinity, the numerator approaches infinity, denominator approaches infinity. So this is the quotient indeterminate form. Use L'Hopital to find this limit by finding the derivative of the numerator divided by the derivative of 6 of the denominator. Take the limit as x approaches infinity. The derivative of the numerator is 12x to the third minus 2x. Derivative of the denominator is 24x to the third. And simplify, as we can see the factor 2x. So we get 6x to the second minus 1 divided by 2x and multiply by 12x to the second. Cancel out. And this becomes the limit of 6x squared minus 1 divided by 12x squared as x approaches infinity. Substitute or see the function as a numerator approaches infinity and the same as the denominator. So it's still in the indeterminate form. Then we continue using the L'Hopital at the next step by finding the derivative of the numerator divided by the derivative of the denominator. X approaches infinity. The derivative of the numerator becomes 12x. The derivative of the denominator becomes 24x. Simplify to get the value 1 over 2 as the limit for x approaches infinity. Another example, limit of the 2 tangent x divided by secant square x as x approaches pi over 2. As you recall the graph of the tangent, it has vertical asymptotes at the multiple odd of the pi over 2. The secant squared, which is the reciprocal of the cosine, as x approaches pi over 2, the value approaches 0. So when it divided by 0, it approaches infinity. Similar to the tangent x, as x approaches pi over 2, the tangent approaches positive infinity. Use L'Hopital or apply L'Hopital to find the limit of this quotient. Find the derivative of the numerator divided by the derivative of the denominator. The derivative of the numerator or the derivative of the tangent x is secant square x. Derivative of the denominator using the chain rule to get 2 secant x multiplied by secant x tangent x. We can cancel the secant square. So now it becomes, and also 2. Take the limit as x approaches pi over 2. Simplify to be the limit of 1 over tangent, which is 1 over sine over cosine, and we rewrite it as cosine x divided by sine x for our convenience to find the value. Now take the limit as x approaches infinity. Cosine pi over 2 divided by sine pi over 2. Sine pi over 2 equals 1. Cosine pi over 2 is 0. Since this is not one of the indeterminate forms, 0 over 0 or infinity over infinity, so the value of this limit is 0 over 1 or just 0.